Okay, so let us get started with chapter 11 that deals with substitution reactions and elimination reactions. So this kind of reactions can take place on alkyl halides or any other compound that will have a potentially good leaving group, like a bromine. So you can have halogens, or you can have other groups that can depart from the organic molecule. And that is what we will call a leaving group. And so we can have, as I said, we can have substitutions or eliminations. Well, in chapter 6, we learned a very easy way to recognize a substitution. Substitution is when you have one group that leaves and another group that comes in and takes the place of that, right? I said this is just like in sports. One player goes out, the other player goes in and takes the place of the previous one. The elimination reaction is very easy to spot as well, because in the starting material, in this case, we have no pi bonds, right? While in the product, we have one pi bond. More pi bonds in the product than in the starting material. Bingo. There you have an elimination reaction. Well, so let's give an example, a very specific example of a substitution. And that could be, for instance, a compound like a 1, 2, 3. So that is a 1-bromopropane reacting with the cyanide anion. And the cyanide anion is taking the place of bromine. And that's how we form this product. So let's put some labels here at some of the species we have. Very often we will refer to the organic compound that is experiencing the reaction as the substrate. This is the substrate. Or we can refer to that as the alkyl halide in this specific case. The group that is attacking and taking the place of the bromine, we will say this is the nucleophile, the cyanide group. The group that just departed, the bromine, we will call that the leaving group. Leaving group. So that is the leaving group. Let's go back to the previous slide, and let's see the kind of things that can happen when you have an alkyl halide. So you have two possible scenarios. Scenario number one will be that the alkyl group will be replaced by the nucleophile. So the leaving group is departing, the nucleophile is taking its place. So that will make it a substitution. Substitution. If we have instead, instead of having a nucleophile, we have a base. The OH can also behave as a base. You may remember that. So here in this case, a pair of electrons, and we have 3 lone pairs here in the OH. So a pair of electrons of the OH can help us to abstract one proton from the substrate, and then with that pair of electrons we can make a double bond and the bromine leaves, right? So there we have again, in this case we will call this not a nucleophile, the OH, but we will call it a base, because instead of getting attached to a carbon atom as it did in the previous reaction, in the substitution, in this case the OH is abstracting a proton to form a water molecule, and we are forming a pi bond in the organic compound. So this is a moment when I say, very often when teaching this part, I will say, until now, McMurray was teaching us that all the things, all the reactions that we were learning were either black or white. So if you use mercury salt, you will get this. If you use sodium borohydride, and if you use borane and hydrogen peroxide, you will get that. When you have such and such substitution, the reaction will always go like this, or will always go like that. So then now in chapter 11, I say, welcome to the real world. In the real world, things are not all black or white, but there is a lot of gray. So, and here we will have quite a challenging situation where we will have to discriminate based on many different factors on how the reaction will proceed. So, different types of mechanisms of reaction that we will have. For the substitution reactions, we will have two flavors. We will have nucleophilic substitution SN2 or nucleophilic substitution SN1. And for the elimination reactions, we will have elimination E2 or E1 or E1CV, three different flavors. So what is the meaning of this SN2, SN1, etc.? Well, this number here, 2 or 1, is telling me something about the molecularity of the reaction. How many species are involved in the formation of the transition state? And how many species will determine the kinetics of the reaction? So if I have a number 2, that means that I have 2 species that will influence the rate of the reaction. In this case, the 2 species will be the substrate and the nucleophile. And the substrate and the nucleophile. So that will be the SN2. In the case of the SN1, the rate of the reaction depends only on the concentration of the substrate. And there is absolutely no dependence on the concentration of the nucleophile. So we will go studying in detail the SN2, the SN1, E2, E1, E1CV. And for each one of these, we will pay attention to the influence of several different aspects. For instance, we can look at the kinetics of the reaction. Kinetics of the reaction, so does the reaction depend on the concentration of the substrate and the nucleophile, or depends only on the concentration of the substrate? Stereochemistry. Stereochemistry. If there is a chirality center, it's going to be quite interesting to see if the chirality center will remain or not. Is there an inversion of the chirality center? Is there a retention of the chirality? Or do I start with a chiral compound and then I get as a final product a racemic mixture? Energy diagram. So we can see at the energy profile, and that is going to be different between SN1 and SN2. Substrate. What is going to happen if I change the nature of the substrate? If I use a primary halide, a secondary halide, or a tertiary halide, how is that going to influence the rate of the reaction and the outcome? Leaving group. What happens if instead of having a bromine, I have a fluorine? Well, carbon-fluorine bond is pretty strong, so that is going to make more difficult the substitution, right? And then how about the nucleophile? If instead of using cyanide, if I use bromide, what reaction is going to be faster. So there is a lot of work ahead. We will have to study all of these things in great detail. So I'll stop here and we continue in the second installment.